Welcome back, guys. Since day 6 is going to be probably our shortest day of the chapter, I thought we'd probably have some time to just very briefly take a look at back at day five's multiple choice questions. So if you'd like to double check these with me, you are more than welcome to. If not, if you feel pretty good, you can go ahead and skip to day 6. But for the rest of us who are wanting to make sure, let's take a look. Name the plane represented by the top of the box. We see points A, B, J, I, and D, C. So any combination of those three that are non-collinear are going to be what we're looking for. And looks like B, C, D. B, C, D. 3 points, all on the plane. And that gives us the top of that plane. How about an easy one? Name the ray that is opposite of GE. Well, here's ray GE. Opposite means going in the opposite direction. Looks like point H is involved there. Another case of A, GH. May's Internet Services is designing websites. She's noticing an increase in her customers over a period of 5 weeks in a row consecutively. So based off the graph, let's make a prediction or a conjecture, an educated guess about the number of customers May might have in the 7th week. Well, first week 1, second week 3, third week 5, fourth week 7, fifth week 9, sixth week looks like it's going up by 2s. I'm thinking 11. Name the ray in the figure. Again, remember, we start from the endpoints and then go out. So our endpoint is C, so C, option C is out of the question. D right here, that is a line. That's not going to work because this is a ray. CD, they have a line segment. Well, this isn't a line segment. Once again, this is a ray. It's got to be A. Ray CD. Number 5, name a fourth point in plane STZ. Well, here is S. Here is T. Ooh, and this is where things get interesting. Here is Z. So this isn't going to be one of the flat planes that we see maybe on top or left, bottom right. No. This is going to be a diagonal plane because from S to Z and then from S over to T, what does that mean for our fourth point? If we're going to have a flat diagonal plane, that means T is going to have to go down to, you got it, Y. And then connect those. So we have that diagonal plane inside this shape. And so Y was the missing piece. And then finally, how about number 6? Which plane is parallel to plane BDHF? So this plane right here. Well, this looks like it's on the right side of the box. So we're probably going to want to look for one on the left side of the box. Because if you look, this plane is going to intersect here. This plane is going to intersect here. Pretty much every plane is going to intersect either at DH or at BF except for A, C, G, E. Check it out. This is the only plane that will never intersect. The one that's on the left side will never intersect the one on the right side. And so that is ACGE. If there's one word I would use to describe kind of the end of this week in geometry, it's going to be angles, would be our word here. Because we're going to be really making sure we understand how to measure angles, the different kinds of angles. You see here we've got a great sequel going on, part 2. Maybe not the greatest sequel ever made, but not a bad one either. And you can really see this in our standards, identifying vertical, adjacent, complementary, supplementary. All of this having to do with angles and being able to then use those to solve problems. Because angles can give us a lot of insight into geometric shapes, the severity of what we're looking at, and it just starts from the basics. Let's throw it back to the old middle school days when we talk about what different angles look like as far as maybe using a protractor as our backdrop. So I'm going to do a few of these with you guys, and then I'm going to let you try some on your own. Now notice we've got ADF down here. We've got a good old-fashioned 180-degree angle. And take a moment. What point is the vertex for every single angle on this protractor? That's right, point D. Point D is the vertex for every single angle. Whether it's ADB, ADC, EDF, it doesn't matter. D is always the crux, it's the vertex. So let's take a look here, and keep in mind we're going to be using these numbers depending on whether we're going left to right or right to left. So ADB, ADB. Now we're in luck because A looks like it hits at 0 on the protractor, and B hits at 25. So from there to there is a total measure of 25 degrees. ADB, 25 degrees. How about FDE? F to D to E. Now be careful. Since we're going to be going left to right here, let's start with this 0, and we're going to use the bottom bracket numbers. So from F to E, looks like E hits at 35. So from FDE, we're talking 35 degrees. And again, you don't have to label all these on the protractor, otherwise that might get a little confusing. I'm just doing it to show you. How about BDC? Now here's where we have to be kind of careful. We're not starting at 0 anymore. So BDC, B to D to C. So left to right. Again, this looks like it hits at 25 right there. And C hits at 80. So how far is it from 25 to 80? Well, you can do a little math. 80 minus 25. And you end up with 55 degrees. Last one I'll do with you guys, and I'm going to turn you loose. CDE. C to D to E. So we know, once again, C is at the 80 mark. And it looks like E is hitting at, up here, the 145 mark. And so again, simple subtraction is going to get you that answer. 145 minus 80, 65 degrees. And so what I'm going to let you guys try is I'm going to let you guys work on numbers. Let's go 5. Keep you on your toes. 8 and 9. Kind of bounce back and forth a little bit here. 5, 8, and 9. Take a moment to pause and try those out for me. All right, you can go ahead and take a look here. See if you went 3 for 3. 80 degrees, 145 degrees, and 155 degrees. And like we said for number 10, ADF, that is a straight angle. So we know that, of course, is going to be 180 degrees. Now get ready. I'm about to take you back to 2016 here. AC ray AC. Ooh, here's that word, bisects. Remember, bisects. That means to cut an angle into equal halves. Angle DAB, dad. And we see angle DAB is this whole angle on the outside here, with C being, looks like a point on the interior of this angle to create this ray. Now if DAC is 58 degrees, which we see there, What would be the measure of the whole angle, angle DAB? Well, if that's 58 degrees, and we know ray AC bisects this angle, what's that going to mean for CAB? Oh, that's going to mean it's going to be 58 as well. These are congruent angles thanks to the AC being a bisector. So our question is, what will the whole angle be? What will angle DAB? B? Well, if it's half and half, then 58 degrees plus 58 degrees is going to give us our answer. So we add those together, and you find out that the whole angle is 116 degrees. By the way, Dad kind of reminds me, RIP, little lunchbox. Let me hit him with them for the one time here. RIP. And of course, he went out in a ball of flames, so we got a rep. Now, on a little bit less serious note, we've got ourselves a pretty interesting looking design down here. We got kind of a straight line with a bunch of rays. In fact, 3 different rays shooting out from the left, 1 ray shooting up to the top, and 1 ray shooting down from the bottom if you want to get technical with it, and you see as a common endpoint. And what I'm going to do, guys, is I'm going to give you a chance to pause the video, and let's just do some labeling here. Let's label which angles are congruent. Let's label what we know about each angle. Take some time, pause the video, and when we come back, we'll see if we match each other. Check it out, guys. I actually tried to color coordinate this so you could kind of see where I got each of these pieces of information. We know CE bisects DCF. Well, that means this piece, this angle, and this angle are going to be congruent. They're 2 halves of the whole. Now, we're also told CG bisects FCB. So here's FCB. So CG is going to bisect that, so these pieces are congruent. Now, we're told that DCE is 4x plus 15, and ECF is 6x minus 5. And we want to find the measure of angle DCE, which right now is being called 4x plus 15. So how can we do this, guys? Let's think algebraically here for a second. What do you think we can do to solve? Because in order to find one of these angles, we're going to need to know what x is. How can we solve for x? Well, we know this angle and this angle are congruent. And if we have values to represent both those angles, we know we can set each of those values equal to each other. If this angle is congruent to that angle, then 6x minus 5 is equal to 4x plus 15. And from there, this just becomes a 3-step algebra problem. Combine the variables. Combine the non-variable numbers. And divide. Now here's the tricky part. So many people are going to stop early here. What did they ask us to find? Find the measure of angle DCE. DCE. Well, we haven't found that. We found what x is. But we've done the hard work, the heavy lifting. All we have to do from here, plug that back in. And so 4 times 10 plus 15. Once you plug 10 in, and we know that, that's going to give us the measure of angle DCE. 4 times 10 is 40 plus 15. We're looking at 55 degrees. So, that one was kind of interesting. That's going to be one of our tougher problems of the day, this and one other one. So if you need to, guys, you can go ahead and pause, stand up, stretch, do what you got to do, and we only have 2 problems left. Last page and last pair of problems, guys. I'll go ahead and warn you, I know it can be tougher when they don't actually give you the geometry visually. When you have to construct it yourself, sometimes that makes things a little bit tougher. But again, if you need to look over something more than once, that's okay. And look for the big picture here. Like, for example, we know that there's going to be a point inside of an angle. And we already know one of our angles, LIN. That's going to be 100 degrees. So I'm going to kind of rep that right here. We know we've got L, put L here. We know I is the vertex. And then there's N. And we're told that LIN, this is 100 degrees. From there to there. Okay. So far, so good. Now we're told that we have a point X in the interior of that. Let's kind of see what that's going to look like here in a second. Because we're also told there's going to be an angle with X on it, LIX. LI, and if X is in the interior, LIX, we could put a ray right there, and now X is in the interior of this angle. And we're told that the measure of LIX is going to be 14t. So LIX, that is 14t right there. Now XIN is going to be t plus 10. Okay, so we want to know 3 things. What's the value of t? So what does t equal? And then what will this angle be, LIX, and what will XIN be? So 3 things here. And again, don't overcomplicate things, guys. Start with the basics. We know the whole angle is 100 degrees. So won't that mean that this part plus this part is going to equal the whole? Remember, angle, add, postulate. So 14t, let me do this in a different color here. 14t plus t plus 10. Ooh. That's a 10, by the way, my bad. That plus that is going to equal the whole, 100. And so let's do some combining like terms here. 14t and t is 15t. Subtract 10 over. 15t equals 90. We divide by 15. And it turns out that one of our answers is t equals 6. But again, that's just one of the things they wanted us to find. Now, we can take that and plug it in for t to find what these 2 individual angles are. So, I'll go orange. The measure of LIX is going to be equal to 14 times 6. So the measure of LIX will be, I believe that's going to be, is that 84? Yep, 84 degrees. And then for XIN, this will be a little bit easier. 6 plus 10. So 16 degrees. And there are 3 pieces. Now I'm going to warn you. I'm going to let you guys try number 4 here. But number 4 is going to be a little bit different. Just be ready for that. Actually, I wouldn't say different. It's going to be pretty similar. So take your time and see if you guys can knock out number 4. I just wanted to unpause so you could double check and make sure you set everything up right before we started getting into any of the answers. So see if you agree with me here. You can see I've got everything kind of color coordinated based off the individual information given. So if you're good with that, you can pause, and here in a second, we'll check our answers. So to start, we know part plus part equals whole. Angle addition postulate says this piece plus this piece should equal the total. We see that up here. You combine your variable like terms, you combine your regular number like terms, you end up with S equals 30. And once you know what S is, we can plug that into both these pieces. You find out that angle GHZ is really 85 degrees. And hey, how about that? Angle ZHI, you plug that 30 in, it's 85 degrees too. So these are congruent angles. That means HZ is an angle bisector. So how about that? HZ is really an angle bisector. Now, as we wrap up, I'm going to be talking with the other geometry teachers to see what we're going to do about a quiz. Normally, this would be on day 8. Stay posted. I'll be sure to get you some feedback on this just ahead of time to see what maybe we'll do about it. But in the meantime, guys, you can go ahead and knock out our multiple choice practice. We have 7 problems, and this is a great summation of everything we've done up to this point. We've got really good info and practice problems from everything from day 1 all the way up to day 5 and day 6 today. So if you have any questions, please let me know, and I'll be talking to you guys soon.